We're gonna learn about static electricity. So before taking start, let's ask some questions from ourselves. Like you have to ask these questions from yourself. That have you ever touched a metal door and felt a small shock? And the next question you can ask, have your clothes ever stuck together? And the third question is, have you seen lightning in the sky? If yes, then what you felt after that? Like there must be a shock. Now we're going to learn that how that shock occurs and what's the background story of that shock. Before that, you should know in this static electricity what electricity is. Electricity means electric charge. The next question going to be what is electric charge? So electric charge is the basic property of matter that causes objects to push or pull each other. Like it is the property because if something is repelling or if something is pushing or if something is attracting, it means there is electric charge in that thing. So you should know that answer, that why something is causing attraction or repulsion. It means there is an electric charge there in that thing. Now, as I told you that electric charge is a property of matter. So now you should know what matter is. So if you can see the thing or touch it or it occupies space, it is matter. That's what matter is. Okay, so here if you see matter is made up of tiny particles. For example, if you're having any object with you, okay, you are having ruler, so that is matter. So matter is made up of tiny particles which are named as atom. Okay, which is named as atoms. Now, states of matter. In what state matter can exist? So matter can be solid, matter can be liquid, or either matter can be gas. And these are the examples you can read. Stone, ice, water, milk is liquid, and air and oxygen is gas. So all these are the matter. Now, what's not matter? You should know about this. That what's not matter? Where charge is not building up. So, light is not matter, heat is not matter, sound is not matter, electricity is not matter. Because, as I already told you, that matter exists in these three states. Is light a solid, liquid, or gas? Is heat a solid, liquid, or gas? So, you should know about this and what really the matter is. Now, let's move toward our next point. Now, we do know that what electrical charge is and how it forms, where it forms, and in what state that matter exists. Let's move toward next part, that we can't see atoms. That's a fact that we can't see atoms because they are so tiny, and even if you put one small dot, there are millions of atoms in that small dot of pencil. Okay, so we can't see atoms with our eyes, but everything is made of atoms. That's a fact. Now, the next question comes that what's inside the atom? We have to start from the matter, and that matter is made up of atoms. And now we are moving toward the smallest single atom, that what is inside of that atom. So, an atom has three main particles. Those three main particles are proton, electron, and neutron. See, I have put the picture here. So this is a picture of a single atom. This red one is neutron, this green one is proton, and then the one surrounding these neutron and proton are electrons. That's how an atom looks like, and neutron and proton together named as nucleus. Now let's move toward the simple definitions. Proton has positive charge, electron has negative charge, and neutron has no charge. You should keep this thing in mind, that electron and atom is made of three particles, and those three particles are proton, electron, and neutron. And which charges they are having? Neutron, no charge. Proton, positive charge. Electron, negative charge. Now, you should know that protons and neutrons are in the center of the nucleus, as I have shown you here in this picture. And next is electrons move around the nucleus. That's also I have shown you that these electrons in the blue color moves around the nucleus. Normally, towards the next step, which is that atom has equal protons and electrons. So overall, an atom is neutral. This is the key point to understand, that an atom is having equal number of protons as well as electrons. So overall, it's neutral. It means it needs something to move from one place to another, like either it's rubbing, either it's friction. It needs something to move, because overall it's neutral. Now, let me tell you one thing, about electrons. You have to write this point on your notebook. Now let's move toward electrons. Electrons can move from one object to another, but protons are stuck in the nucleus. Like these, protons are stuck to the nucleus, while these electrons can move from one object to the other. Okay, so let me. You should know about this, that electrons can move from one object to the other, but protons are stuck in the nucleus. And when you do rubbing, or when obviously rubbing causes friction, so this friction makes electron moves. Before there is no movement, before the electrons are stuck around the nucleus, but when you cause rubbing or friction, it makes electrons move. And when two different materials rub together, electrons can transfer from one form to another. Here you should notice one thing: when two different materials rub together, then electrons move or transfer from one to the other. That's what you should know about electrons. Now let's move toward about charge. Is charge is created? Because we just feel shocked by a metal door, or there are many other examples. So the question comes, that is charge created? No, we are not creating, it's transferring by friction or either rubbing. And let's move toward next step, which is what happens when we rub objects. Before we have understand that charge is not created, it is transferred and moves from one object to another. Now, what happens when we rub objects? Let's do the experiments. Because I already told you that by rubbing, this charge is actually transferring, and by that transfer, that attraction is occurring. See, I have told you here that when two different objects rub together, electrons transfer from one to the other. Now, you should know that what happens when we rub the objects. Let's do the experiment. You have to take a rubber, like a ruler, plastic ruler, and you have to rub a plastic ruler or balloon. You can take any of these on dry hair. Now, what happens when you rub both together, like either a plastic ruler or balloon on the dry hair? So this is what happens. Electrons move. When you rub, electrons move because they are two different objects. So electrons move, and the main thing notice is they move from here to plastic. So electrons move from here to plastic. Before, there were equal number of charges on the hair as well as on the ruler or balloon. But when you rub together, the electrons start moving from one object to the other. But which charges are moving right now? Positive, negative. So you should know that those electrons are moving from here to plastic. But you should know that why? Why from here to plastic? Because plastic attracts electron more strongly than here. This is the answer of this question. That why not from plastic to here? Why here to plastic? Why electrons are moving from here to plastic? Because plastic attracts more electrons, while here has the ability to lose electrons and plastic has the ability to gain electrons. Now, let me tell you one thing here, that plastic ruler or balloon gain extra electrons and becomes negatively charged. That's what I told you, because it has the property to strongly attract, to strongly gain the electrons. So plastic or ruler gain electrons and it will become negatively charged. Next is loss of electrons. So here loss electrons, it means it becomes positively charged. Now let's move toward the next step. Why does the ruler attract paper pieces? For this is a second example, and you have to read it. This example, you have to read it by yourself, the one written in the blue color. Let's move toward electric charge, because till now we know a lot about electric charge, that where this charge is occurring, like it's occurring on the matter, and matter is existing in three states, and after that we come to know that every matter is made up of tiny particles which are named as atoms, and then in those atoms there are protons, neutrons and electrons. And the one thing to notice is electron moves from one object to the other while protons stuck to the nucleus. And we have also learned one example that how this transfer is occurring and why it's from here to plastic. Why not plastic to here? So till now we have learned these things, like why when it becomes negatively charged, when it becomes positively charged. So after these concepts, now let's types of electric charge. Before we have we have a few idea, like little idea. Now we are getting the clear idea of it, that what are the types of electric charge. So you should know there are only two types of electric charge. One is positive and the other one is negative charge. Rules to remember here is that opposite charges attract and same charges repel. See, positive positive repels, negative negative repels, but opposite charges attract. Next step is, now we know about that what charges, because electricity is produced from a charge, and now till now we got all the idea about charge, that how it's creating, what are its types, when it repels, when it attracts. Now the whole world was static electricity, because our today's topic is all about static electricity. So static electricity is static electricity because it's still not moving. So they don't flow like electricity in wires. Those electrons don't flow like electricity in the wires, because it means it's not continuous. It occurs whenever you rub, when there is friction. So that's why it is called static electricity, because before those electrons and protons are still, they are at the same place. They are not continuous, they're not in the constant continuous movement. So you have to keep this definition in mind, that electricity, static electricity is called static because electric charges, those positive and negative charges, build up on an object and remains at the rest instead of flowing continuously like wires. Now, after getting idea about static electricity, let's take the natural example of static electricity, which I've already told you, which is of lightning. So what happens in lightning is, in the sky, clouds move. We already know that clouds are moving, yes. So when clouds are moving, charge builds up inside the clouds. I'm going to show the picture of it as well. So clouds move, charge build up inside the clouds. Okay? When too much charge collects, air can't hold it and charge steadily moves and cause lightning. It means lightning is equals to a very big spark. Okay, let me show the example of it. Yes, here. That why lightning is dangerous. When charges build up too much, air breaks down and electricity flows suddenly. But what's air breakdown? That must come in your mind. That what's air breakdown? Yes. So normally air is an insulator. It does not allow electricity to pass, because insulator never allow electricity to pass until it reaches to its limit. For example, a rubber has its limit, and after that specific limit, it's gonna broke. In the same way, insulator is also having the limit. Normally, air is insulator. It does not allow electricity to pass. But when the charge becomes too strong, the same way when you stretch the rubber too much, so the rubber gonna broke, or it's gonna stretch too much, that is electricity gone. So in the same way, when charge becomes very strong, it pushes electrons to the air, which is insulator. So air loses its insulating property. That's how air breakdown occurs in lightning. This is the example for lightning, that how it's happening. See, these ice plus water droplets rubbing in. After that, these positive charges collects on the top, and these positive and negative charges collects here, while these electrons stuck here. So it means this cloud is acting as an insulator and it's not letting these electrons to go outside. See, clouds hold electrons like an insulator because inside the cloud, the water drops and ice are rubbing and they are causing the friction. Because of friction, the electrons starts move. So the cloud at that time is acting as an insulator, like it's holding electrons and it's not letting those electrons go. But when there are too many electrons inside the cloud, it causes the air breakdown. Like this cloud will not be the insulator anymore. Okay, that's it for this natural example, that how it's happening. You can watch it again, you can listen to it again, go back, and whatever I said, you can again listen to it and understand it, that how this is actually happening. Now let's move toward the that Benjamin Franklin story. I already told you about his that he what he did, that he flew a kite in the storm, tied a metal key to the string, and then electric charge traveled down and a spark jumped from the key to the ground. So he proved that lightning is electricity. And after that, these modern scientists and other scientists have done these processes and told that actually these are charges which are traveling. Like those were the charge from which moved from that string of kite to the ground. So today's scientists use safe equipments, not kites, to prove themselves. Now let's move toward the next thing, that what causes static electricity. What causes static electricity? So static electricity is not magnetism. You have to understand static electricity is about positive and negative charges, not north and south pole. So you should understand this important point, that static electricity is not magnetism. And important thing to know is that magnetism is about magnets and north and south poles, while static electricity is about electric charge, which is of two types. Let's move toward what creates charge. Again, I'm repeating the concept so that you don't forget and you can correlate all of them together. So what creates charge? Movement of electrons creates a charge. When the electrons are moving, it means charge is created right now. And charging by friction. When this movement is happening, then how this is happening? So charging by friction, this is the next topic. Everything is made up of atoms again. Again, we are revising those concepts we have learned in the start. So charging by friction, what's happening at that time? Everything is made of atoms and atoms contain protons, electrons, because we were talking about the two types of charges, proton and electron. Now, when you rub two objects, electrons move and protons does not move. And example is balloon and here. Balloon gains electrons and here loses electrons when you rub both of them together. This is called charging by friction. This is called charging by friction. And balloon plus here attract because they develop opposite charges, because they are two opposite objects, not the same ones. Also, there's another example of walking. When you walk on the ground, it causes friction, right? It means now after getting friction, it means your body is charged. The electrons are moving now. Now you need an other opposite charge so that they can attract and you can get a shock. So when you're walking, friction is happening at that time and body becomes charged. Understand this point. Body becomes charged after friction. Touch metal. When you touch the metal, charge flows. The collected charge flows and suddenly you feel shock. It means metal is a conductor, so charge moves quickly. It means metal is a conductor, so charge moves quickly before the charge was collected in your body. Now, let's move toward what conductor and insulator is. Obviously, after that, this is what comes in your mind, Like metal is conductor. What conductor is? So conductors let electrons move easily from one object to the other. Examples of conductors are metal or human body. Okay, human body can conduct. Electron can easily pass from the human body. If there are too many electrons, so they can easily pass to human body. Insulators. Insulators in which electrons are fixed. They are not moving. The way So in insulators, electrons are fixed, and examples for insulators are plastic, rubber, and glass. See, I've already told you, when you stretch the rubber too much, it loses its electricity, it loses its elasticity. In the same way, it means that now it's not insulator anymore. Now it can pass those electrons very easily. The same way the lightning occurs. So that's why plastic stays charged, metal loses charge quickly. This is the most important point. It means that insulator stays charged, but metal loses charge quickly, and the things which loses are positively charged. Right? Let's move toward electric field. What electric field is? For this, you should know that how does a charged object attract. Okay, in order to know what electric field is, you should know that how does a charged object attract without touching? Because you are not even touching it, but still a charged object attract because of an electric field around the material. Okay, what is electric field? Electric field is region around a charged object. You are having any object, and the region around that object is called as electric field. Okay, so the example for electric field is charged comb elects paper, attracts paper, no touching, fields pull the paper. Like there's no touching, but still that field is pulling the paper. That field in the comb is pulling the paper without touching. So that field is named as electric field. Region around the charged object where force attracts, where force acts. This is a definition for electric field. That the region around charged object where force acts. Next is what are charged particles? You already know that what are charged particles and what is electric charge. And then when if there is no charge, it means there is no electricity. You can stop the video and you can pause it and read these points, because I already told you. I wrote it again so that we can correlate the things again. Now let's move toward what's the unit of electric charge. The unit of electric charge, in the same way, there are units, kgs, liters. These are units, right? You measure things in kgs or liters, like the mass is in kgs. In the same way, the charge unit is coulomb. You always measure charge in a coulomb unit. So you should know about this. Next is electric charge is measured in coulombs. That's what I already told you. The unit for charge is coulomb. So it is named after Charles Augustin de Coulomb. It was the name of the scientist who have discovered this charge. So he discovered that the force between charged objects depends upon how big the charges are and how far they are. So force, that how with what force, with how much force they're going to attract or repel. It depends that how big the charges are, how big those charges are, and how far apart their charges are, like how much at the distance they are, like they are too much far apart or they are close. On these two things, force between charged objects depends upon. Now, if there's a bigger charge, it means the stronger force. And if they are closer, it means the stronger force. Obviously, if something is big, it's gonna attract or repel with more force. And if something is close, it's gonna be attraction gonna be more stronger. In the same way, electron is negatively charged particle and electron has negative charge. This is why only electrons move during charging. Why? Because they can move easily, they exist outside the nucleus, and they are very small. That's why electrons move during charging. Protons don't move. Well, I already told you about protons. You can read it again. And the next point for proton is they are heavy. That's why they can't move easily. While electrons are not heavy. They are light in weight.